Welcome to the Cybersecurity and Cloud Podcast, the podcast where we learn from cybersecurity experts how to stay safe, private, and secure on the cloud and in code. CSCP is hosted by Francesco Cipollone, your cybersecurity friend with a passion for all things cyber and sharing stories of other professionals with you. This episode is brought to you by the generosity of Phoenix Security Limited. Phoenix helps startups and enterprises solve complex software security supply chain visibility by leveraging the power of correlation and contextualization. Discover how Phoenix Security helps CISO and security engineers act fast, prevent burnout, and implement DevSecOps at the speed of cloud. Phoenix Security. Correlate, contextualize, and act on risk with one click. Let's dive in.
Hello everyone and welcome back to the Cybersecurity and Cloud Podcast. This is your host Francesco, and today we have a discussion on something that was close to my heart during my evolution, that is vulnerability management and network. How do we intersect the both? So we tried to record this, actually, to be fully honest with you guys, in the previous season, and we broke it, unfortunately. So we're here today with Micheal Smith to record this again. So we'll try to play back, but actually we evolved from that discussion, and we're here to discuss about this and application security and how can you misuse certain things to actually your advantage. So Micheal is field CTO of Verkara, but I'm not going to tell you whole spiel. Micheal, welcome to the show. Tell us a bit more about you.
Thank you. So job and title. I am the field CTO for Verkara. We just rebranded in early April. We used to be New Star Security Services, but that was kind of this vestigial name, and so we've gotten rid of that. We've moved to Verkara, and really, we do DDoS mitigation. We do a lot of DNS. We do a lot of web application firewall. Okay. So a lot of my background, I joined the Army when I was 17. They said, hey, you're pretty smart. Sent me to language school. I learned Russian and then Serbian. And I was in the intelligence field for a good 8 years. Got off active duty. While I was there, I was living in Germany and I taught myself Linux. So I became a really good Linux system administrator. Got off active duty, messed around for a year or so, and then started doing a lot of Linux system administration. And it was the .com era. So it was, 1999, 2000, and I started doing a lot of LAMP stack programming. Mm-hmm. So it went from just Linux administration to, oh, hey, here's a database. Can you manage that? To, oh, hey, we need some web forms built. So true to form, I built a lot of very good, technically accurate, but very, very ugly web applications.
I like how you picture it, like very accurate, but very ugly, because
that's and today I still do that. Yeah. So I still do that. I do slides, I do white papers, I do things like that are very accurate, but very, very ugly. That's why I have marketing people to make it pretty. Okay. But I did that, and then the .com era crashed, and I said, okay, so I've got this background in security, different kinds of security, right? So ranging from physical security to network or radio intelligence, different kinds of things. And so I said, look, I either need to move to California or DC. And 2 weeks later, I had a job in DC writing security documents. So I worked my way up through. I did lots of crossover between engineering, security management, program management, GRC, did a lot of slices of that and just basically worked my way up from position to position.
Nice. So you've seen a lot of field in cyber. Why did you pivot in that field? Like, what's like, instead of being a programmer and keep on being like developing cool stuff and building cool stuff with ugly interfaces, what made you steer towards the security?
Well, it's where demand is. So you can influence a lot more things and help people solve problems, right? So what I was running into a lot was engineering teams. So not even software engineering teams sometimes, but also just system integration teams. Mm-hmm. Right? And they get to this point where they were like, hey, we want to build this thing. And the security team would come along and say, no, we can't do that because, well, it's in the government space. So because physics is the... Right, or they say no, right? Like, oh, we can't do that, and like, well, why can't we do wireless? This is 2006.
People say no.
Yeah. And so I found out that I could help people because I can absorb the regulations and policy and stuff like that. And then I could turn around and help guide them through that process to say, okay, let's how do we actually get to yes on this?
Mhm.
And in the government, it's funny because you can come in and say, okay, how do I get your people to work with these people? Right. And they're like, oh, that's no problem. You could talk to my people anytime. I'm like, okay, that's not what they've been saying for the past 6 months, but okay. But you just told them in a room full of people that was okay. So I worked on that, did a bunch of stuff. I was a compliance officer for TSA's embedded device program. So I did a lot of IoT security. And again, same kind of problem, right? Like we've got a device, I called them toasters, but we've got a device. It's not an IT device, but we attached a computer to it to do data acquisition. And we connected that computer to a network. So the compliance people, rightly so, come along and say, hey, you're connecting to the network. Here are our rules. And we said, okay, well, we can't do some of these things, right? Like
patch a scanner,
right?
patch an HR machine.
You can, but it's a little bit different, right? What you're looking at, you manage it more like you do firmware upgrades, and you have 6 months of functional testing. So being able to explain that and work in that world and help move that along helped out a lot. And it was like some simple stuff like, we have a device, go talk to the manufacturer, show them what we test for, basically give them all of our security testing that we do, so that way they can perform that inside of their QA process. So by the time that they deliver a device to us, it'll get a first-time pass on security testing. Okay. And the reason for that is because if there's 6 months of functional testing, right? Like you're trying to find bombs. Yeah. Okay. Yeah. And so if you make a change, you do an engineering change, which is like a electronic engineering or even like detection algorithms. If you make a functional change, it takes 6 months of testing to make sure that it still operates and you can still do the thing that you should before you can deliver an item. So if they bring something to us and it fails a security test, then it's another 6 months before you can actually have equipment that they deliver that you can buy. So
that's not how we build software. But that's not how we build software.
It's not how we build software. But when you build hardware devices, that's what you have to do, right? Yeah. So it takes a lot longer to make changes in hardware. And so it was it was IoT, it was shift left, lots of the concepts from DevSec with this, kind of a waterfall delivery model that they had. It's physical devices, right?
You can't touch it, something that is like...
It's a lot harder to do iterative cycles when it's hardware.
And that's what we have such a challenge in the, I believe, in the regulation against OT and IoT. That is like operational technology and traditional patch management is very, very different if you have something buried in the middle of the sea, a SCADA device in the middle of the sea, or an MRI machine, or even a TSA, or like a bomb detector, or anything else that nowadays is connected, has a machine, has network information, has data.
Yeah, exactly. And then I think the last one, and then we can talk vulnerabilities and stuff. I left that program doing all the IoT pieces, and I went to Akamai. I worked for Akamai for a good 10 years, including running their incident response team from 2012 through 2015. And then I went to Asia and I was the regional CTO for security. So interesting time there when I was running CSERT, because we were basically doing threat intelligence. Like, what are the bad guys doing? What does that look like? How does that stack up against us? Understanding that our scope of service was protecting web applications. Right. So normally CSERT, you're dealing with, user went to a bad site, they got their laptop pwned, so we clean that up. Our scope was specifically, let's look at web application attacks and DDoS attacks. Okay.
Because Akamai is an aggregator of data and handle vulnerability for basically half of the world.
Yeah.
And has a lot of intelligence.
Has a lot of intelligence, more data than they know what to do with. So we did the intelligence side, which was how do we actually detect and block stuff? And then we also managed incidents that were big incidents. So for instance, Hacksgiving, right? Which was it was Thanksgiving of 2014. That's a US thing, I get it. But November of 2014, one of the widgets that you add to your website, they got compromised, and the attackers put up, you do a JavaScript include from this service, and the attackers put in their own JavaScript, was basically overwrite the website. They just used document write and replace the entire website with, in this case, it was the Syrian Electronic Army. So they put their logo there. So by compromising one service, one widget provider, they were able to infect, 100 different large news sites and deface them all in one day. So
what was that?
What was that?
No. When was that?
When it was in November of 2014.
Because when was the Colonial Pipeline and the whole?
Oh, that was 20.
That was more recent. That was more
21.
recent.
Yeah, that was a lot more recent.
Yeah, I think SolarWind and the Colonial Pipeline actually really kick off the horse nest on digital supply chain. But we had incident and issue like maybe not as malicious as we had.
And then there was Log4j or Log4Shell.
They all came in a sequence of things, but I think SolarWind was probably the more malicious one and the one that kicked the horse nest. But we had Strat in the past. We had OpenSSL, Heartbleed, and others that give us a good serious scare.
Yeah, my friend Andy Ellis, he dressed up for Thanksgiving one year as the year of vulnerabilities. So he had a turtle shell, he had a poodle head that he wore, he had a big red heart that he put, that was the heartbreak. So he came as the year of vulnerabilities for Halloween.
I need to do a costume like that, even though it might be only understood in our circle of black hat. And
yes, is correct. Yes, yeah. That was a pretty crazy year. I think that was 2013.
Yeah, we seems to go in waves and then forget about software. I think that's where all of us got kicked off, and I think right now just hit the threshold, and now we all of a sudden realize, oh, by the way, the whole world runs on software. Let's secure our supply chain.
Yeah, and so people have been focusing a lot on that, like, who's has access to what, and what is our software made of? I mean, we like come on, we've known about this stuff for years and years and years. So back in 2016, 2017, I was a security officer for a managed security provider, right? Managed security, so managed SOC, managed NOC, managed data. And we knew, hey, wait a minute, we have access to this customer, this customer, this customer. Why? Because we have to go make changes, right? We knew all about that. And we're like, well, we can't really think about that because,
it's scary.
That kills our business model. Yeah. And so we tried to manage access the best that we could, using jump boxes, restricting a lot of access.
It's different if your code is in the code. It's different if your access is inside the code and is voluntarily given, like Log4j and another supply chain or CI/CD provider, or there is a whole paranoia right now about after the CI/CD incident with Circle CI of keys and other access token that we directly inject a third party. And I think this has been discussing this with Jeff and a few other RASP or dynamic application testing, and there is a whole debate right now of do you need dynamic application testing? Do you need IAST that is really advanced, that is really precise, but also give you access to client memory? So that sometimes is even worse.
Yeah, but this isn't anything new. We've had exactly the same conversation about antivirus software, right? Antivirus software runs in as an administrator on the operating system because it has to access everything. But then because it accesses everything, then you can also target it.
I think we went through a cycle of traditional infrastructure security and stress testing that right now that area, like accessing through a network and bypassing a firewall, is not that easy. And we became good at that, but we forgot the whole software part of it. So that became the soft kind of tissue that people or attackers start realizing, well, actually, instead of like compromising tons of system and trying to bypass a firewall, why don't we punch a hole on the website and install a widget or social engineer somebody? And when 2 or 3, 4 attacks happen and succeeded, it's like, yay, that's an easy entry.
Yeah, and even beyond that, the thing with hacks giving, right, is, well, the attackers couldn't attack the website directly. The website, like, they'd attack their target website numerous times, had success, and the target got smarter and smarter and smarter. So they weren't even attacking the actual target. They were attacking a provider. It's a widget provider, but still it's a provider for that particular website, and compromising that, and then being able to actually achieve their goal by compromising a widget provider.
Yeah, and I think we got, I believe, in these past couple of years, better at detecting, reacting, and jumping on things, because we know that that's an attack vector that is highly compromisable, regardless of where they come from.
This episode is brought to you by the generosity of Phoenix Security Limited. Phoenix helps startups and enterprises solve complex software security supply chain visibility by leveraging the power of correlation and contextualization. Phoenix platform connects to your repositories, scanners, and cloud, correlates all the information, and provides you with a prioritized list of vulnerabilities that need to be addressed first. Discover how Phoenix Security helps CISOs and developers remove friction and maximize the use of DevSecOps professionals at phoenix.security. Phoenix Security. Correlate, contextualize, and act on risk with one click.
I want to pivot in the conversation a little bit on, okay, we know the vulnerability, we know attacker, we know traditional attackers, but how can somebody compromise things or be more malicious with the vulnerability? Can you cause a DDoS attack leveraging a specific vulnerability, or saturate memory, or what can you do other than traditional vulnerability attack or access to system?
Yeah, so something I've looked at a lot, and I've seen it in production, and I did a lot of threat research on it over the years, and that is vulnerabilities in applications that you can then target with application layer denial of service attacks, right? Some of that's a function of the roles that I've had, the role that I have today. Some of it is, oh, hey, that's a neat thing. Like, let me go look at that. And so normally the DDoS mitigation folks, self-included, we normally divide things into 2 tiers, right? You've got network level attacks. So those are either aimed at bandwidth saturation, right? So you just fill up the pipes, and then no more can go in. Or you send a lot of packets per second that fills up the connection tracking on the router, and the router just runs out of the ability to track connections, right? And then the routers roll over and die. So that's the network level DDoS, or sometimes you'll hear it called volumetric, which is kind of a misnomer, but that's okay. There will be no TED talk on that today. We also have application layer attacks, okay? And normally the DDoS mitigation folks are like, oh, application layer attacks, that's a get flood, right? So, while true, wget, index.html, done. Okay.
And for folks that don't are in the P language day in, day out, a get and a post is a traditional request, initiation request. So if you flood, we get a web server, it's like, please give me resource, and you saturate all the channel.
Yeah, exactly. And so you can flood the web server with the number of requests, so that it's like attacking the CPU. Right. So you send, how about this? You send 200 bytes of a request, and it generates a certain amount of CPU load, especially if you're doing like input validation, even web application firewalls, right? You've got a lot of CPU that's used to check that 200 byte request. So that's one way that you can cause an outage. Another way that you can cause an outage is by the web server responding with a large object, right? So if I find, okay, your website has a 10 megabyte PDF, I can go hit that with a get flood, and the web server will actually choke all of its bandwidth trying to return that object. Okay, so that's a leveraged attack. But the thing that really fascinates me is the vulnerability side. A great example is pagination. Okay, everybody sees pagination or pagination, but everybody sees that, you know it. You go to a shopping cart site and you search for men's t-shirt black, and you get a bunch of t-shirts. And there's a field form, usually it's a selector or something, that is how many items to see per page.
Right.
Okay. And the actual process of making a trip to the database, getting page one with so many items on it, and then slicing that up into HTML and spitting that out to the user, that's the process of pagination, right? But I've seen attacks in the wild where there was no input validation on that number of items per page. So you could go in and put, give me 9 million objects per page. And you can add in what we call proxy busting, which is you just add a random key value pair in the query string to make that request unique, right? So, okay, you make one request, you generate a lot of, the application server goes to the database, says, give me every product that's in the database,
and
gets that return, paginates it, slices it up into HTML, just delivers that to the client. And you've done a little bit of, little bit of stuff. Like maybe if that database is large enough, you can choke out the application server. Okay. But if I take that and give it to a bunch of bots, and now I've got, a million endpoints that are now requesting that large database result, that large page, I can choke out the database server, right? Because you can choke out the database server, the application server, the bandwidth coming for that return object. That's a lot more of a leveraged attack, and I can do it with a small amount of bandwidth. Okay.
But do you see the network attacks? Like I've seen a lot of the network attack, the network DDoS are quite famous, and we've seen some spike in the past. Do you think this type of attack, leverage, because they're sophisticated attack, there's not something that you traditionally script because it needs to be targeted to a specific website, to a specific vulnerability, while network level attacks or traditional vulnerability DDoS attacks are pretty generic, so can be scaled, and ransomware people or DDoS people actually work at scale rather than precise attack. Do you see these kind of attacks?
Yes and no.
Okay.
So yes and no, and there's a thing. You do this on the vulnerability side, right? That's why this is a hybrid. That's why it's absolutely interesting for me, right? We know how to play CVEs, web vulnerability scanning, virtual patching. We know how to play that game. We know how to play, here's the volume, we choke out your network game. This sits right in the middle there because I've had DDoS gangs, and what they do is they know that, say, there is a particular piece of shopping cart software. And they know that shopping cart software has a pagination vulnerability that allows them to better do a DDoS on it. And so what they do is they go Shodan for it, right? They go Google Dork for it. Show me all the websites that use this particular version of that shopping cart software. And then they came in and they did this I saw it heavily in December 2010. With the attackers launching a DDoS campaign in November, December, peak shopping season for e-commerce sites, and specifically you could see it because Google hadn't anonymized their search results yet, right? So today you go to Google, you do a search, they anonymize what you were searching for in the refer when you go back to the page, right? You click through and you go to the page. But back in 2010, they hadn't anonymized that yet. So when you went to Google, you searched, you click through, that query string of what you search for would actually be in the refer. So you could go through, as a defender, you could go through your web logs and say, oh, I see that this guy right here, he was actually Google dorking, looking for this particular shopping cart system that we had. Okay.
Yeah, you
and
can
so
pinpoint.
we saw it then. It was a large campaign. It was a month and a half long of the attackers targeting one particular shopping cart just because they knew they could do that particular attack.
That's interesting because, and we're talking about widgets, so we had to mention like the traditional CMS that have a lot of these widgets, and there are tons of widgets that all of a sudden pop up with a critical vulnerability. We're getting better at even fixing those, and I've seen recently, and I was quite surprised actually, some of these CMS content management service and provider actually forcing a patch of widgets that they have. Like I've seen it 2 or 3 times for critical vulnerabilities. So I think maybe we learned a lesson.
Yeah, maybe. There are other fun ones though. There are other fun ones that are out there. One of my favorites lately, because APIs, the web is now APIs. Okay.
Yes.
If you're expecting, even dynamic HTML
or GraphQL.
right? GraphQL
terrifies me.
JSON. One of my favorites right now is nested JSON. Right. So if I submit to an API and I do JSON that is key value pair, which contains another key value pair, which contains another. So basically you nest it down 2,000 levels. Yeah. Well, the thing is the protections to parse it also load it. Right. So you have to set, and we do this today in our web application firewall. We've got limits on what's the largest size of the object, right, that you'll accept in the submission. How deep can the nesting go? And usually, like, if you do like 10 levels, you'll probably satisfy most. If you go, how about this? If you have an API that goes more than 10 levels deep, what the heck are you doing?
Private API.
Right, like, how deep is it? There are a couple others that we actually checked. Oh, the maximum number of children in that for each parent in the hierarchy. There are a bunch of different validations you can do before you load that in and accept it into memory. Right. And so that's like my favorite child today is that one. Right.
Geeking out. And what about, I'm gonna take a completely different tangent. How about filtering out BT requests and other stuff like proxying out or filtering out requests that come from specific LLM, because that's the other super hot topic thing.
That's interesting. I haven't seen that. Well,
I've seen a couple of things.
I don't know if I've seen that. Right.
Yeah, I've seen a couple of things that put proxy for LLM or actually filter out specific keywords out of specific requests to LLM so that you can kind of sanity check either out or in the information.
Yeah, and I've been fighting scraping bots for a long time in various levels of success, various techniques, various types of bots. We saw it. I saw it a long time ago with people that were doing translation bots. And what they would do is they would go to large international retail sites. Okay. And they would look at the English version of a product. Then they would look at the Italian version of a product. They look at the Brazilian Portuguese version of a product. They look at the Spanish version of the product, because some human went in and translated it.
Right.
So then they would actually come in, scrape the site, get every language possible from that site, and then use that to feed their translation algorithms. Okay. So with stuff like that, you won't be able to discriminate that and say, okay, that's Chat GPT, or that's, translation software, or that's something. A lot of times you don't know. You just know that there's a scraper of some kind that's requesting a particular volume, but it's incredibly hard to go from, I see discrete requests, right? Individual discrete requests into a pattern, but I don't necessarily know what's the intent of the person running that bot, right?
Right.
So, are they feeding AI models? Are they just dumping it into a database? I can't really tell. I can maybe sometimes look at the pattern of what they're requesting, right? Which is how I know that this guy is loading different languages. You can sometimes see from the pattern, but a lot of times you can't.
And on the opposite side, on the client side of things, like requests going out, like blocking a completely GPT, but actually becoming the proxy of actually specific words or keywords of requests. So looking inside your traditional HTTP request and being a proxy or a filter of those things that goes to any LLM.
Yes. Yep.
Because that's the other trending thing.
Yeah, that's interesting for other reasons. We could have another TED talk on that. Probably it could be an extended TED talk, but that is evasion. This is interesting to me because we have a filtering DNS resolver service, okay, that has a bunch of different things, but it's got, the big data science piece behind it to actually detect like malware, phishing, ransomware, like all these things. And one of the big things that I'm looking at a lot is things like domain fronting, proxies inside of applications. Domain fronting is basically the fact that your DNS resolution is different from your TLS certificate, which is different from the HTTP host header. So you can do, if you have multiple resources on the same server, say with a content delivery network or some kind of proxy, you can tunnel traffic by lying at each of these three layers. Okay. So, and it's good and it's bad, right? You can use that to evade censorship in your country. Okay. And there is software that allows you to evade censorship in oppressive regimes. Okay. I won't name them by name, but I know they're out there. It's not just the obvious one. There are other ones that are out there, and they use all these techniques, and that's considered a good thing. But then also, if I'm an attacker and I have some kind of a foothold inside of an enterprise environment, I can also use those same techniques in order to sneak my traffic out, right? So when it comes to, I go to a website. Yeah,
there is a fine line between a good hack that is bypassing kind of restriction regulation because every developer is a hacker at heart versus a malicious way to use something. And I used to joke always with my devs that, ultimately it's a very fine line between being a hacker, and hacker is actually a good word. It just got maliciously intent after a while, but actually trying to find way around things.
Yeah, that's why I used to think, for all the D&D nerds, we're all there. I used to think I was chaotic good, but in the past couple of years, I think I've changed my mind, and now I describe myself as chaotic neutral. For the same thing, right?
It's the shift left. It's the shift left of D&D.
It's shift left, yeah.
Sorry, I had to nerd out.
Wouldn't that be the shift right? But anyway,
evil is right or left?
It's usually on the right. But anyway, I call these dual use technologies, right? And it's things like a brick, right? You have a brick. Well, you could use a brick to attack somebody, right? Break somebody's windows out, or you could use a brick to build a house, right? And then you look at all the other things that we do. Vulnerability scanners. You can use them to fix problems, or you could use them to identify things that you want to attack. Nmap fits in there. There's a bunch of different things. And I actually was in a meeting like years and years ago, and they rolled out, the Unix guy. And he said, look, I just have one question to ask. So we did our customer presentation and all that stuff. He's like, look, I just have one thing to ask, which is, how do I know that it's not you that's attacking us to get us to buy your product? Right. And you're like, well, and there's not really only one answer to that, which is you look them straight in the eyes and you say, it's not me because I'm too pretty to go to jail. Right?
That should be the line of every hacker.
Yeah, right. It's not me. I think I would allow people to adopt that. But that goes back to, okay, what you have the ability to do this. Do you use that for good, or do you use that for evil? Or you just use it for chaos, right? Like,
I think that's another tech talk, but I'm afraid we come towards time, and
yeah.
I want to leave everybody, like, we have a tradition here, Micheal, that is leaving everybody with a warm and fuzz feeling. We discuss about a lot of malicious stuff or good stuff that could be used for evil. Let's leave everybody with a chaotic good feeling.
I think that the big positive thing is that in this industry, we spend a lot of time managing chaos. Okay.
Mm-hmm.
Right. It's just like we have the big chaos engine and you turn the crank, and sometimes a nice cute kitty comes out, and sometimes it's a tiger that tries to eat you. Okay. The positive thing there is, by talking to each other, learning from each other, just like we have with all of these vulnerabilities that we've dealt with, we learn from each other. Everybody has their area of specialization, and maybe nobody wants to hear about your mastery of log4j until there's a vulnerability in log4j, and then suddenly you become the expert on it.
I got 2 or 3 guys that became famous overnight.
Yeah. The nature of this industry is that we have to collaborate, right? And collaboration is really the only way to get this thing done. Okay. So that's my positive note, right? Like, talk to each other, go to local conferences, help each other out whenever you can, because you never know when somebody will have the amount of knowledge that you need to actually solve a problem that you have.
So good karma out, good karma in, and stay connected to the rest of the world. Micheal, thank you very much for coming on the show. If somebody wants to find more about what you do or where you write, a lot of this geeking out, do you have a blog? Do you have a site where you collect your thoughts?
Yeah. So here's the thing. My name is Micheal Smith. So good luck. My company is Verkara. So Vercara. So you can find, the usual suspects, Verkara.com. You can go to LinkedIn. You can find Verkara. Then you can click on employees. You can find me there. I do a lot of stuff on the Verkara blog lately, just managing WAF, managing DDoS attacks, dealing with DNS, both recursive and authoritative. So I'm writing a lot of stuff and putting it out, and I'm trying to do a lot more how-to content and explanations and screenshots. So I've got a bunch queued up already that are coming over the next couple of months.
Fantastic. And we're going to have the link in the blog and the link to your LinkedIn profile. So people go, click, follow, because it's quite an interesting, and actually, to be fair with you, not well-discussed topics that pass, because everybody talks about the traditional vulnerability management, but nobody talks about DDoS using vulnerability or leveraging these vulnerabilities. Is out there. So thank you so much for coming on the show, and everybody go dig your WAF, see if you find anything out of today's conversation in your log, and have fun with it. Thank you.
We hope you enjoyed today's episode. Please leave us a review on Apple Podcast and post it on social media tagging Cybersecurity Cloud Podcast for a chance to win a $100 Amazon gift card. Discover other episodes at www.cybersecuritypodcast.com.